Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about how to find X and Y intercepts. And some of this may be familiar because we did talk about it in our lesson on how to graph equations that were given to us in standard form. If you remember standard form, that's the form, let me just put it up real quick. We have AX plus BY is equal to C, and neither a point nor the slope nor the y-intercept is given to us directly from this equation. So generally the easiest way is to find the x and y-intercepts and use those to graph the line for us. So again, some of this will be a bit of review, but we're going to go into a little bit more detail as well. To start things off, let's look at the first two problems. Make this a little bit smaller. So it says label the x and y-intercepts of each function. That means you need to write down the actual coordinates, then answer the questions below. So you have just two questions. What is true about the coordinates of both the x-intercepts? What is true about the coordinates of both y-intercepts? So pause the video, give that a go, and then join us back for a discussion. Okay, so let's label these x and y-intercepts. The x-intercept is where the function crosses the x-axis. So that would be right here. Wow, that was a pretty poorly drawn point. So we have -2, 0. Remember the x-coordinate comes first. Easy way to remember that is that x comes before y in the alphabet. For our y-intercept, we're up here at 0, 4. It's still not a good 4. Third time's a charm. There we go. If I come over to my other function, points are already there, so I just need to label. Let's do the x-intercept first. That is at 2, 0. And our y-intercept is at 0, -3. First question says, what is true about the coordinates of both x-intercepts? Well, those are the ones in blue. Well, if we take a look at the coordinates, right, we have -2 for our x for our x value over there, and +2 for our x over here, but the y coordinates were both 0, right? And this is something we've talked about before. Any point on the x-axis, right, any point on this pink axis has a y value of 0 because we haven't gone up at all, we haven't gone down. We've stayed right at 0 in terms of y. So for the x-intercept, the y-coordinate is 0. Well, if we look at the y-coordinates of both, if we look at the y-intercepts, we've got 0, -4, we've got 0, -3. This time, the x-coordinates are both 0. And that makes sense because if we look at the y-intercept, we haven't traveled in the left direction or the right direction, right? We've stayed right on that axis. So our x-coordinate is always going to be 0. And this is essentially, if you can remember this idea, the takeaway, that if we're trying to find the x-intercept, the y-coordinate must be 0, and if we're trying to find the y-intercept, the x-coordinate must be 0, you're basically going to be able to solve any of these problems. Let's look at another representation. Let's look at a table. And it says find the x and y-intercepts of the equation given by the table below. This time you don't get to see where it crosses on the graph, but you can figure that out from the table. So pay attention to the two things we wrote down up above and see if you could find both the x-intercept and the y-intercept. So we know that for the x-intercept, our y value is 0. So we go to the table, right? We're looking at our y value. And y is 0 right here. So our x-intercept is at 5, 0. For our y-intercept, we need to look at where the x is equal to 0, and that turns out to be right here. So our y-intercept is at 0, negative 10. So quite easy in a table. If the zeros are given to you, then you can easily find the intercepts. Let's move on to our third representation, which would be an actual equation. Here we have to do some work. We can't just look and label. If we think about the x-intercept, we just talked about it before. For our x-intercept, y-coordinate equals 0. So what we can do is we can take our equation, right, 2y minus 12 is equal to 5x, and substitute in 0 for y. So I get 2 times 0 minus 12 is equal to 5x. I get negative 12 is equal to 5x. And if I divide both sides by 5, I get negative 12 over 5, or negative 12 fifths, is equal to x. So my x-intercept is at negative 12 over 5. If we wanted to write out the coordinates of that point, we would have negative 12 fifths, 0. For the y-intercept, it's just the opposite. Right? We know that our x-coordinate equals 0. So we start with our general equation, or rather the specific equation, and then we do some substitution. So instead of substituting in 0 for y, I'm going to substitute in 0 for x. So that gives me 2y minus 12 is equal to 0. If I add 12 to both sides, that gives me 2y is equal to 12. And if I divide by 2, I get y is equal to 6. So my y-intercept is at 6. If you write down the coordinates, we would have 0, 6. Okay, so same idea is going to apply to the most of the rest of the problems in this packet. So we have another one here. You do the same thing here, same thing here, right? Same thing here. Equations may look a little different, right? They may be a little bit more complicated to start off with. The inverse operations may be different. But that idea is the same, of substituting in 0 for the other coordinate of the intercept you're trying to find. Let's recap here. So when given an equation and asked to find the x-intercept, we need to substitute in 0 for y and solve for x. When given an equation and asked to find the y-intercept, we need to substitute substitute in 0 for x and solve for y. If you guys ever forget, right, well, which do I substitute in for, the x or the y? Well, sketch a little graph, sketch a graph with a line, and just make up your own numbers. Right, if I look at the x-intercept here, well, we could say maybe that's around 2 or 3 for the x value, but the y value has to be 0. Right, and same thing for the y-intercept, right? That x is always going to be 0. The y is some positive number. Maybe we'll call that 3. So if you ever forget, well, which am I supposed to substitute in 0 for, sketch a little example to figure out which of those coordinates must equal 0. Now, there's one more example we need to go through. It's down here with the table. You'll have a couple others to try. Sometimes a table will not give us a point where the x or the y coordinate is equal to 0. Right? If I look at this table, if if I look at this table, none of the y coordinates are 0, none of the x coordinates are 0. So I can't just look and circle the points that are the x and the y intercepts. For this, you're going to have to go through some extra steps. You're going to actually have to come up with the equation of the line and then substitute in 0 for x and 0 for y in different steps to find your intercepts. Good news is we have written equations of lines from tables in our very last lesson. Think about our general form. It's going to be point-slope form. That's what we're going to start with. It's going to be y minus y1 is equal to m times the quantity x minus x1. Right? That m represents our slope. So we can pick 2 points. I'm going to choose these two to find our slope. I've got my x1, my y1. That's not my y1. That's my x2. And my y1 and my y2. My slope formula, right, that's equal to the change in y over the change in x, which is y2 minus y1 all over x2 minus x1. So if I substitute those in, my y2 is 10 minus my y1, which is 16, all over negative 1 minus negative 3. Make sure you see that those are double negatives. So I get negative 6 all over positive 2. Negative 1 plus 3 would be positive 2, which gives me a slope of negative 3. So I found my slope, and I already know what my x1, my y1 is because I labeled it in my diagram or in my table. So I have y minus y1, which is 16, is equal to my slope, negative 3, times the quantity x minus negative 3. I can do some simplifying here. Y minus 16 is equal to negative 3 times the quantity x plus 3. And now I have an equation, and I can go ahead find both of my intercepts. I'm going to erase my work for slope. If you don't have it down, just pause the video and get it down before you move on. I don't want to scroll down and lose what we have here. So now we go through the process from above, right? If I'm going to find my x-intercept, I'm going to substitute in 0 for y. So I'm going to get, I'll start from the beginning. So I get 0 minus 16, and I'll distribute my negative 3 over here. Negative 3x minus 9. This gives me negative 16 equals negative 3x minus 9. Add 9 to both sides. Numbers are a bit off today. That is going to give me negative 7 is equal to negative 3x. And if I divide by negative 3, I'm dividing a negative by a negative, so I get positive 7/3 is equal to x. And the point of the x-intercept would be 7/3, 0. Now we just need to find my y-intercept. So again, I start with my initial equation. This time I just need to substitute in 0 for x. So I'm going to get y minus 16 is equal to negative 3 times 0 plus 3, that quantity. Y minus 16 is equal to negative 3 times 3. Y minus 16 is equal to negative 9. And if I add 16 to both sides, that is going to give me y is equal to positive 7. So that's my y-intercept. And my point would be 0, 7. So the only extra steps we had to do in this problem were coming up with our actual equation. Once we did that, we could then employ the process that we used on the questions from above. Okay, that's going to do it for this video. As always, enjoy the rest of your day, and I will look forward to seeing you next time.